Welcome to the show. We look up at the night sky and immediately assume certain things: vast distances, unimaginable scale, and the relentless march of time. Every star we see, every galaxy we track, is governed by a clock that never seems to stop ticking. But what if we paused that clock? What if the universe, in its most fundamental state, had no need for a before and an after? It's a concept that moves beyond the simple physics of motion and gravity, touching on the very nature of reality. Could the cosmos be a complete, static structure where change is just an illusion we perceive? We're not talking about science fiction. We are diving into advanced theoretical physics, where some of the biggest minds are challenging our most basic assumption that time is real. If this kind of deep dive into the underlying architecture of space and existence sparks your curiosity, give us a gentle like and subscribe. It helps us share this exploration with more curious minds. Settle in, because we're about to explore a universe where the ultimate countdown may have never started. We all know the experience of time as a current, constantly pulling us forward. Look around you now. Notice the quiet hum of the world. Maybe you're listening at night when everything feels still, or maybe it's the middle of the day. Whatever the hour, take a second to just feel that moment. Feel it, and then acknowledge how quickly it's already gone. Time has that specific, unyielding quality. It feels present, then it's already past. This constant motion is so familiar, it's the bedrock of how we understand existence. We build our lives, our calendars, and our plans around this idea that time is a steady, universal river. But tonight, we need to gently ask ourselves if that river is truly fundamental to the universe, or if it's just the most comfortable way we've found to measure change. Imagine trying to see the universe not through the lens of a clock, but through a lens where everything simply is, not ticking, not flowing, just a complete structure of existence, fully present all at once. For most of us, this thought sounds impossible. It feels like pulling a rug out from under reality itself. But what if the physical laws that govern the cosmos don't actually need that rug? What if our concept of time is simply the best tool our biological minds have for organizing a massive, static reality? We begin with the most familiar place, your own experience of the day. From the moment you wake, the day has a specific, linear shape. Morning leads to afternoon, and afternoon fades into evening. You perceive yourself walking a clear path, one event always following the next, always moving ahead. This is the arrow of time, the perception that time must only move forward. Yet, when we look at the deepest equations of nature, this arrow often disappears. The laws that describe the movement of planets, the laws that describe the interactions of subatomic particles, they often don't truly care about which direction time is running. They describe relationships, patterns, and specific states of being. Time is often something we layer on top of those relationships because, without it, our sequential brains struggle to make sense of the flow. This is the point where our personal experience separates sharply from what modern physics tells us. Our intuition screams that time is absolute, rigid, and shared by everyone equally. But a century ago, this intuition was challenged by the insights of Albert Einstein. He began to show that time is not a universal constant, but something dynamic, something that stretches and bends. It depends entirely on the observer. The core idea is this: time is not the same everywhere. It is affected by two primary factors: speed and gravity. When an object moves extremely fast, approaching the speed of light, which is roughly 186,000 miles per second, time for that object slows down relative to an observer who is standing still. This is not science fiction. It is called time dilation, and it is a measurable fact. For example, scientists use highly unstable subatomic particles called muons. Muons are created in the upper atmosphere when cosmic rays strike the air. They decay or fall apart very quickly. They typically only last for about 2.2 microseconds before they vanish. If time were absolute, these muons should never be able to reach the Earth's surface, even traveling near the speed of light, because they would decay too fast. Yet, they reach us. Why? Because from the muon's perspective, traveling at that extreme speed, its internal clock runs slower. The time it takes to reach the surface is compressed, allowing it to complete its journey before it decays. To us, the observer, the muon's clock has been slowed down by its speed. This phenomenon is also proven by the Global Positioning System, or GPS. The satellites that make GPS work orbit the Earth at about 8,700 miles per hour. Because of their speed, their clocks run slightly slower than clocks on Earth. Additionally, the satellites are further away from the Earth's gravitational pull, which is the second factor affecting time. Gravity is a warping or curving of the fabric of space-time. Near a strong gravitational field, like that of Earth, time slows down. Since the satellites are further away, they experience a weaker pull of gravity, causing their clocks to run slightly faster than clocks on Earth. These two opposing effects, speed making the satellite clock run slower and weaker gravity making it run faster, must be continuously calculated and corrected by engineers. If they didn't make these tiny adjustments, the GPS system would accumulate an error of about 10,000 meters, or about 6 miles, every single day. This required daily correction proves that time is not universal. It is personal. Time is a measurement unique to your frame of reference. If time is relative, if it can be stretched and compressed based on where you are and how fast you move, then it cannot be the fundamental unmoving reality we assume it is. It means time might simply be a flexible dimension, a tool the universe uses to organize change, not the essence of existence itself. And this leads us to the deeper, stranger questions in physics. What happens when we look at the universe as a single, complete entity? Imagine a vast, detailed painting. You are standing right next to it, watching the artist apply individual brushstrokes. In that moment, you perceive movement, process, and time. You see the before and the after of each stroke. Now, step back hundreds of feet. The individual brushstrokes disappear. The movement stops. What you see is the entire, finished image, a complete landscape existing all at once. Some physicists believe the universe functions in a similar way. When we observe the world from our limited, fast-moving perspective, we see the individual brush strokes, and we call that perception time. But if we could step back, if we could look at the cosmos from the perspective of the entire system, would we find that time disappears? This idea is formalized in certain areas of quantum gravity, notably through an equation called the Wheeler-DeWitt equation. This equation attempts to unite the laws of general relativity, gravity, with the laws of quantum mechanics, particles. The astonishing thing about the Wheeler-DeWitt equation is that when it describes the universe on its grandest scale, the variable for time drops out of the equation entirely. The equation simply describes the state of the universe without reference to when that state occurs. It suggests a universe that is a static, unchanging configuration, a block universe where every moment, past, present, and future, is equally real and exists simultaneously, like pages in a massive, open book. We don't travel through this book. We simply exist in different sections of it, one after the other. The movement we feel, the flow of time, is simply the process of our consciousness moving through the unmoving spatial configuration of that book. If this view is correct, the ultimate question is not, can the universe exist without time? The better question is, does time only exist because of how we look at the universe? This doesn't invalidate your daily schedule or your wristwatch. Time is still deeply useful. It still dictates your day and organizes civilization, but it might not be the fundamental engine of the cosmos. It may be the mechanism our brains use to turn an overwhelmingly vast and static reality into a sequence we can cope with. It is, perhaps, the mechanism of human experience. And that insight leads directly back to Einstein's revolutionary realization. Before we can truly imagine a universe without time, we must first understand how time became flexible in the first place. There was a moment in history when time broke free of its rigid absolute chains and became linked to something else entirely: space. To grasp this linkage, we must follow Einstein's journey, where he showed that space and time are not two separate things, but one unified, interwoven structure called space-time. Understanding this unified fabric is the essential step before we can ask the even deeper question. If space and time are fundamentally connected, what happens to space if time truly vanishes? We left off with the revolutionary insight of Albert Einstein that space and time are not separate measures of reality, but a single, unified material. This interwoven structure is called space-time. Any movement you make through space, whether you are walking down a street or orbiting a distant star, automatically changes your rate of movement through time. But even with that warping and stretching, we still feel time's constant pressure, the unyielding rhythm of the clock. We still feel like we are travelers, moving strictly moment by moment. Take a moment to step back from that feeling of constant motion. We briefly touched on how even a small mental shift, like when you are totally focused on a task and lose track of the hour, can change your experience of time. That simple change in perception is a critical hint. If time can feel different depending on the mind that is noticing it, perhaps time is not a solid pillar of the universe, but something that emerges. This idea of emergence means that a simple, fundamental reality combines in such a way that it creates a complex phenomenon. Think about temperature. Temperature is not a single particle. It is the overall effect you get when you observe billions of tiny molecules moving, shaking, and bumping into each other. If you look at one single molecule, you cannot measure its temperature. You need the collective motion of the whole group. In the same way, time might be what emerges when billions of things in the universe change all at once. If every particle were perfectly still, if nothing moved or altered its state anywhere, there would be no way to track time. No motion, no difference, no time. Time and change might be two sides of the same coin. This concept that time is simply a measure of change leads us directly to a profound and difficult idea in physics: the block universe. For centuries, we have lived with the notion of a sharp present, a fleeting boundary that separates a fixed past from an open future. But in the geometry of space-time, the past and future are simply directions, no different than north and south or up and down on a map. When you travel to the North Pole, you do not worry that the South Pole has suddenly ceased to exist. Both directions are part of the same, complete Earth. The block universe views time in the same way. Every event that has ever happened or ever will happen is already permanently fixed within the 4 dimensions of space-time. The universe is a single, complete, static block. If this is true, then our experience of motion is what creates the illusion. Imagine watching a movie. A film reel is nothing more than thousands of still pictures or frames lined up in a sequence. Each frame already exists. The final scene of the film is just as real on the reel as the opening scene, even though you haven't seen it yet. When the projector shines light through those frames at a quick speed, usually 24 frames per second, your mind connects the still images and creates the perception of continuous, flowing motion. You see a story unfolding, but the entire story was complete before you even sat down. In the block universe theory, the universe is that complete film reel. The past is simply the frames we have already seen. The future is the frames that are yet to come. The present is the single frame we are viewing right now. The feeling of time flowing is the direct result of our consciousness moving from one fixed frame of reality to the next, stitching them together into a sequence we can understand. Our entire civilization runs on the conviction that the clock is telling us the fundamental truth of the universe. But what exactly does a clock measure? A clock does not reach out and grab a cosmic current called time. It simply measures motion. Whether it is the swing of a pendulum, the vibration of a tiny quartz crystal, or the decay of an atomic nucleus, a clock is just a small, reliable machine that tracks a reliable, repeating change. If every moving part inside a clock instantly froze and the atoms stopped vibrating, the clock would still exist, but it would cease to measure anything we call time. This strongly suggests that time is not an independent entity, but simply a sophisticated way of tracking motion and change. This takes us to the deepest point of disagreement in theoretical physics, known as the problem of time. We currently have 2 great, successful theories that describe the universe. The first is general relativity, which describes the very large planets, stars, and galaxies, and treats time as flexible and connected to space. The second is quantum mechanics, which describes the very small atoms and subatomic particles, and generally treats time as a rigid, absolute clock that exists in the background. When physicists try to combine these 2 theories into a single unified framework, a theory of quantum gravity, they encounter a persistent issue. The mathematics they use, such as the famous Wheeler-DeWitt equation, often results in a universe where the mathematical variable for time simply drops out of the equation entirely. The equation describes the state of the universe without reference to when that state occurs. The laws that are supposed to describe the ultimate reality of the universe seem to suggest that, at the most fundamental level, there is no time at all. If the ultimate equations of physics show a universe without time, then the small, quiet feeling you get when you lose track of the clock is actually a powerful clue. In that moment of distraction, when your mind stops intensely tracking the frames, you come closer to the truth of the block universe. You are not rushing to catch up with time. You are simply allowing your consciousness to rest in a space where counting seconds is momentarily unnecessary. This realization changes the entire conversation. If the universe doesn't run on time, then what is the true, deeper mechanism? It must be something that exists outside of sequence, outside of before and after. This underlying reality, which does not care whether you measure it or not, is the space we must now explore further. We need to look at what happens when the four dimensions of spacetime are viewed not as a road we travel on, but as a complete map that already contains every single destination, permanently and all at once. Clocks, then, are like highly reliable metronomes. They do not create time. They simply provide a steady rhythm for our minds to follow. We take their orderly ticking as proof that time is an absolute reality. But all they are truly doing is marking the periodic change of their internal mechanism. Without that rhythm, without the gears turning, the crystal vibrating, or the number display changing, you would still exist. The universe would still exist. The structure of everything would remain unchanged. You would simply lose your human sense of moving through it. Even Einstein himself hinted at this profound idea. After his close friend Michel Besso passed away, Einstein wrote a letter to the family containing a now famous line: "For us, convinced physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." He was not being a poet. He meant it mathematically. The core equations of relativity give absolutely no special privilege to the moment we call now. From the universe's geometric point of view, there is no single universal clock striking a shared moment for everyone. What is now for you might technically be later or earlier for someone else who is moving at a different speed or sitting within a stronger gravitational field. Time, therefore, is local, flexible, and ultimately personal. And if time is personal, based on your perspective and location, it cannot be the fixed, fundamental backbone of reality itself. But if clocks don't measure something fundamental, why does the flow of time feel so inescapable? Part of the answer lies in how our brains are physically organized. Our memory links one moment to the next in a continuous, forward-moving chain. We cannot remember the future. We cannot feel the present exactly the same way we felt the past. We live in a narrow, active window of experience, and that window creates the forceful illusion that we are being perpetually carried forward. The ticking clock only reinforces that illusion, like a conductor guiding a song that has already been entirely recorded. You have all felt this illusion loosen its grip before. Recall those moments when you were deeply absorbed in something, perhaps a complex conversation or a piece of music, and you looked up, surprised to see that hours had gone by in what felt like minutes. It is not that time sped up. It is that you simply stopped measuring it. You stopped intensely flipping through the frames. For that brief while, your consciousness stepped out of the rigid sequence. This is not just a philosophical trick. Physics points in the exact same direction. In quantum mechanics, the rules that govern particles at the smallest scales, time is often not fundamental. The equations that describe the configuration of quantum states do not even need the variable for time to be written down. They only describe how one configuration, or state, is related to another state. Time, in that deep-level view, is something we create when we stand back and begin to compare those static configurations, when we mark a before and an after. Without an observer to make that comparison, the math simply does not require time at all. This is a challenging fact to accept because it contradicts our most basic instincts. We live by clocks, we set alarms, we celebrate birthdays, we watch the hands move, and we naturally believe that we are moving with them. But from the universe's perspective, there may be no movement at all. Every tick of your clock might just be the means by which your mind walks through a vast landscape that is already completely there, unchanging and whole. And if that is true, it leads to a question that might be even stranger. If time is an illusion, why does it have rules? Why does it only move forward for us? Why do we remember the past, but not the future? Why does every broken piece of glass stay broken and never spontaneously reassemble itself back onto the counter? For most of human history, time was simple. It was the same for everyone, everywhere. The sun rose, the sun set, and that rhythm was considered universal. It did not matter who you were or where you stood. Time was the one thing you could count on to be steady, unshaken by the world around it. At least, that is what everyone believed, until a quiet clerk in a Swiss patent office began to see it differently. Einstein did not set out to destroy time. He was trying to solve a much smaller, specific puzzle. Physicists of his day firmly believed that space and time were completely separate entities. Space was where events happened. Time was when they happened. One was a stage, the other was a ticking clock on the wall. But when Einstein began to look closely at how light behaved, he noticed a fact that absolutely refused to fit the existing framework. No matter how fast you moved, no matter if you chased it or ran from it, light always traveled at the exact same speed, approximately 186,000 miles per second. That single, stubborn fact changed everything. If the speed of light never, ever changes, then something else has to be flexible to compensate. And what Einstein discovered was that the flexible element was time itself. Imagine two people standing apart. One is completely still, the other is moving quickly. Each carries a perfectly accurate clock. You would expect those clocks to tick in perfect sync, but Einstein's equations showed they would not. The moving person's clock would run genuinely slower compared to the one at rest. Not broken, not malfunctioning, just slower. And it would not just be the clock. Everything about that person, their heartbeat, their thoughts, their internal flow of time would slow down relative to the observer standing still. This was not a small adjustment. It was a revolution. It meant there was no single, universal, now shared by everyone simultaneously. Time was not a singular river carrying everything forward at the same fixed speed. It was a flexible fabric, stretching and bending depending on how you moved and where you were. Two people could live side by side and experience time differently, and neither experience would be fundamentally wrong. Einstein's insight did not stop with speed. He realized that space and time were not separate at all. They were one thing, space-time, a single connected framework. You cannot change one without changing the other. Gravity, instead of being an invisible, pulling force, was the physical bending of that fabric. A massive planet or a star presses down on space-time like a heavy bowling ball on a sheet, and everything nearby follows the curve that is created. Even time itself bends around those curves. A clock on Earth ticks slightly slower than a clock far out in space, not because it is broken, but because gravity has literally changed the local flow of time. If this feels abstract, you have already lived inside this effect without realizing it. Your feet are slightly closer to Earth's strong gravity than your head, which means by an immeasurably small, tiny amount, time at your feet is running slower than time at your head. You do not feel it, but the difference is there, and it is measured using incredibly precise atomic clocks. The same effect is so strong near a black hole that time for someone standing close to it would slow almost to a complete stop compared to the rest of the universe. What Einstein uncovered was that time is not a fixed backdrop. It is an active part of the stage, and the stage can be stretched, tilted, and curved. The ticking clock is not a fundamental cosmic rhythm. It is a local rhythm, one that depends entirely on where you are and how you are moving. This is precisely why his work shook the foundations of physics. If time can change, then it is not the absolute, universal thing we once believed it was. It is a feature of the way the universe arranges itself, a detail of the geometry of space-time. And if it is only a feature, then maybe it is not truly fundamental at all. Even stranger, Einstein's equations do not actually need time to flow. They do not describe a universe that evolves in the sequential way we picture it. Instead, they describe a structure that simply exists. Past, present, and future are all laid out in that structure, like a single, complete map. You do not need a clock to describe the whole map. You only need a clock if you are walking across it one step at a time, experiencing it from the inside. This is why many physicists now think that time, at least the way we experience it, might be a secondary effect. From a higher, more complete view, the universe could be timeless, a complete whole, where what we call yesterday, today, and tomorrow all coexist. Your mind simply moves through it in a single direction, and that motion creates the overwhelming feeling of time passing. It is a radical idea, but it fits the math. But before we get lost in the physics of timelessness, there is one major challenge we need to address. If time isn't fundamental, why does it feel so unavoidable? Why does it seem to have a strict direction, always moving forward and never back? If you have ever stood by a massive river, you know how steady it seems. Water flows past, and you can almost convince yourself it has no choice but to follow that path. That is how time feels most of the time. One second follows another, one moment leads into the next, and we never question whether it could do anything else. But in the strange language of physics, the river does not always flow at the same speed. Sometimes, in the quiet depths of the universe, it slows almost to a stop. This is not a metaphor. It is one of the most confirmed effects in science. Time does not tick the same way everywhere. If you take a clock to the top of a mountain and leave another one at sea level, the one at the summit will run slightly faster because it is experiencing less of Earth's gravity. But if you compare those two clocks, the one at the mountaintop and the one at sea level, carefully enough, the difference is absolutely real. Time itself is moving at two slightly different speeds. The difference is minuscule, but it is measurable by modern atomic clocks, which are precise enough to track time down to 1 part in 10 million billion. These experiments, such as one called the Pound-Rebka experiment and those involving optical clocks, confirm that time slows down when gravity is stronger, even over distances as small as a few feet. If you push that effect far enough, it becomes undeniable. Imagine hovering close to a black hole. From far away, someone watching you would see your movements slow down dramatically. Your voice would stretch out into silence, and your clock would almost seem to stop. To you, everything would feel perfectly normal. You would see your own hands moving, your own breath rising and falling. But in the outside universe, ages would pass in what felt to you like mere minutes. This is the confirmed reality of time dilation. It is not an illusion created by your mind. It is built into the very structure of reality, into the geometry of space-time itself. Einstein's equations predicted it, and experiments have measured it repeatedly. Astronauts on the International Space Station age a tiny fraction of a second less than the people on Earth because of their speed. The GPS satellites that guide your car and phone must constantly account for time dilation. If they did not, their navigation signals would drift and fail completely within minutes. Even your phone depends on a continuous, quiet correction that admits time is not absolute. If time can stretch and bend like this, then it is not the constant, rigid background we always imagined. It is more like a property of the universe that bends and adapts to local conditions. When you truly think about that, something strange happens to your perspective. You start to realize that the universe does not experience time the way you do. It does not have a single shared clock ticking in unison. It has countless local rhythms, each one tied to the local conditions of speed and gravity. Each location is its own little river of time. Stand next to a black hole, and your river slows. Drift out into empty, intergalactic space, and it speeds up. The universe contains all of these rivers at once, each flowing at its own pace, and yet they coexist perfectly. No argument, no contradiction, just a quiet, hidden flexibility in the fabric of existence. That flexibility has a certain calmness to it, because if time can run at different speeds, then your personal now is just one of countless ways the universe measures itself. It is not the universal present, it is just yours. Someone else, somewhere else, moving differently, or feeling the pull of a different gravity, is living through a completely different stretch of time. And in the framework of physics, both of you are correct. There is something almost peaceful about that realization. You are not racing against a single universal clock. You are moving through your own. And even that clock is not fixed. It can be stretched, slowed, and shifted by the weight of space itself. In the deepest parts of the cosmos, time practically comes to a halt. Near the edge of a black hole, a second for you could last forever compared to the rest of the universe. If that is possible, then the idea of time as an unstoppable, singular river starts to look less certain. Perhaps it is not one river at all, but a network of streams, each one winding and bending depending on where it flows. And if that is true, then it is much easier to imagine a deeper reality where the streams vanish altogether, where the riverbed is dry, but the landscape, the universe itself, remains. This is where the concepts begin to truly connect. If time can slow almost to nothing near a black hole, then there must be places or conditions where it does not exist at all. Some physicists believe this is exactly what happens at the deepest, most fundamental level of reality. Time, like temperature, emerges only in certain collective situations. The way temperature only makes sense when you are talking about trillions of atoms moving together. For a single atom, temperature does not exist. For the universe at its most fundamental, quantum level, maybe time does not exist either. But before we get there, it is worth pausing to consider the profound implications for the way we see the world. Every time you look at a clock, you are seeing just one version of time's flow. Every time you wait for something, you are leaning on a sense of time that is only local, only yours. Beyond that, in the larger universe, the river bends in ways you cannot feel. It slows, it speeds up, and in some places, it nearly stops. And if time can pause, even in that hidden way, then it is not hard to take the next step. What if it could vanish completely? If you think of your life as a string of moments, it feels natural to imagine each one being born and then vanishing as the next arrives. But what if none of those moments actually go anywhere? What if every single one of them simply exists, fixed, unchanging, always there, whether you notice it or not? This is one of the strangest ideas to come from modern physics, but it is a serious one. In the deepest theories of the universe, there are no equations that say this moment becomes the next. The math does not speak in terms of flow or motion. Instead, it describes static structures, relationships between events, patterns that simply are. In that picture, what you call now is just one location in a vast landscape of moments. The past is not gone. The future is not waiting. They all exist at once, side by side, woven into a single, static, timeless reality. This is not an easy thought to sit with, because it is so different from the way you live. You wake up, you eat breakfast, you watch the sky shift from morning to night. It feels exactly like movement, but that movement might not belong to the universe. It might belong only to you, the observer, walking through a static structure, like someone reading one page of a book at a time without realizing the rest of the pages are already there, printed and complete. Physicists sometimes call this the block universe. Imagine all of time laid out like a massive, four-dimensional map. Every point on that map, every event, every single moment already exists. You do not see the entire map because your consciousness can only stand in one place at a time. You call that place now, but the rest of the map is no less real. You have just not reached it yet. This view comes straight from the confirmed math of Einstein's theory of relativity. In his equations, there is no master clock ticking away in the background. There are only fixed relationships between events in space-time. Your now is demonstrably different from someone else's now, and there is no cosmic referee declaring which one is the true present. That means the universe does not privilege this instant over any other. All moments exist equally, even the ones you think of as long gone or yet to come. If this feels unsettling because it seems to erase the difference between past, present, and future, remember that it also solves a puzzle. If time were truly flowing, where would it be flowing from? And where would it be flowing to? If the future does not exist yet, how could you ever arrive at it? And if the past no longer exists, why can you remember it so vividly? The block universe sidesteps all of that. Nothing flows, nothing vanishes, nothing begins or ends. It just is. Now, you might wonder, if every moment exists, why do we not experience them all at once? The answer may lie entirely in how our minds work. Your brain stitches together a sequence of events to create a workable story. Without that story, you could not function. You would be overwhelmed by a reality that contains everything simultaneously. Instead, you experience a single slice at a time, and that slice feels like the present. From that perspective, time is less like a river and more like a spotlight slowly scanning across a stage that was already built in its entirety. There are even experiments that hint at this hidden timelessness. In quantum mechanics, particles do not seem to have definite positions or paths until we measure them. Between those measurements, the math that describes them does not contain any reference to time. The universe, at its most fundamental level, might not be ticking. It might simply exist as a network of possible states, all connected, with time appearing only when you zoom out far enough to see the pattern your mind expects. If that is true, then every single moment, this one included, might be permanent. When you laugh at a joke, when you take your first step, when you look up at the stars for the very first time, those moments do not sink into nothingness. They remain. You have only moved on from them. This way of seeing the universe does not make time meaningless. It just changes what time is. Instead of a force carrying you forward, it becomes a way of navigating a landscape that is already there. The past does not disappear. The future is not waiting. You are just walking from one fixed moment to the next. And if that is the case, it raises a question that is even more intriguing. If time is an illusion created by moving through these unmoving moments, what happens if you could step outside of that motion entirely? What would you see if you could stop and look at the whole structure at once? Not just one moment, but all of them. The movement you feel so strongly, the constant push forward, is tied to something else that we have not yet fully addressed. Why does the universe insist on moving toward greater disorder? The movement we see in the cosmos is deceptive. When we talk about the universe expanding, it is natural to picture distant galaxies rushing away from us, as if they were running across a fixed stage. But that is not what is happening. The galaxies are not flying apart because they are moving through some empty container. The container itself, the fabric of space, is actively growing. Distances between the galaxies widen, not because they are traveling, but because the very reality of space is unfolding beneath them. This idea alone is strange enough, but it leads to an even deeper question. If space can stretch, can time be left behind? We tend to link the two so tightly that it is almost impossible to separate them. Einstein's work tied space and time together into one single entity, space-time, where changes in one immediately affect the other. When mass bends space-time, it bends both space and time. When you move faster through space, you move slower through time. They are woven together, inseparable in the way we usually imagine the world. And yet, the expansion of the universe seems to play by rules that do not always match our intuition. Space can expand. We have confirmed it by observing the cosmological redshift of distant galaxies, the stretching of light waves as the space between us grows. Distant galaxies drift farther and farther from us, not because they are moving through space, but because there is simply more space between us every second. And this expansion does not require anything visible to happen to time itself, at least not in the sequential way we experience it. Time does not visibly stretch when the universe grows. Your seconds do not get longer just because a galaxy billions of light years away is receding faster than you can imagine. This suggests something subtle but powerful. Space and time are tied together, but not always in the synchronous way we assume. Space can evolve, grow, and change in size, while time seems to be something we only experience locally in the middle of it all, as if we are standing still while the cosmic fabric stretches around us. Now, imagine taking that to its absolute limit. What if the universe could exist without time altogether? What if what we call time is only an emergent property? We have used the analogy of temperature before. A single molecule does not have a temperature. It has kinetic energy. Temperature is a word that only emerges when enough pieces interact and move together. Maybe time works the same way. Maybe it is not fundamental. Maybe it is something that only appears when matter and energy arrange themselves in certain highly structured ways. There are serious theories in physics that treat time exactly like this. In some approaches to quantum gravity, the attempt to unite quantum mechanics with Einstein's space-time time simply disappears from the equations entirely. What is left is a description of the universe in terms of relationships, not motion. Things do not happen in order. They just exist in a static relationship to one another. The before and after that you and I depend on are not there. And if those theories are correct, then time is something like a shadow cast by space and matter. When the universe is dense and structured, the shadow looks clear and steady, providing a clean sequence. But if you were to peel the universe back to its simplest, most fundamental state, the shadow would vanish, and with it, time. Space would still exist, stretched, curved, and structured, but without the ticking clock we experience inside it. This might sound like a contradiction. How can space expand if there is no time for it to expand into? But that question only exists because of the way we are used to thinking about change. In a timeless universe, expansion would not be something that happens. It would simply be part of the universe's structure. The universe would not grow. It would simply be big, with that size built into its very nature. And what we see as growth would only be our way of walking through that structure, one slice at a time. This is hard to picture, but not impossible. When you look at a map, you do not see a road getting longer as you trace it with your finger. The road was always that length. You are just following it. In the same way, space might not be stretching in time. It might simply be what it is, and time is nothing more than the way we experience our journey across it. If this is true, then it brings us closer to something truly remarkable. A universe where time is not the stage, but a perspective. Not a thing that exists on its own, but a way of looking at something deeper. When we talk about the universe, we almost always frame the conversation in terms of beginnings. We picture a singular moment when everything started an instant, when the first light appeared, when time itself began to tick. The Big Bang is the story we are told, and in many ways, it is the best story we have. But what if it is not the whole story? What if the universe did not begin at all? It is a strange idea, because our minds are built on sequences. You wake up, then you eat, then you move through your day. One thing follows another, and you cannot help but imagine the same is true for everything, even the cosmos. If there is a now, then surely there must have been a before. But the laws of physics do not universally share that intuition. They do not need a beginning. In some of the deepest theories we have, the universe does not start. It simply is. The Big Bang, in this view, was not the first moment of time. It was just one feature in a much larger, static structure. Time, as we experience it, might emerge only inside certain conditions that did not exist before the universe cooled and expanded enough for clocks, change, and sequences to make sense. Outside of that highly structured slice, there may be no before and no after. This is not just idle speculation. In quantum cosmology, there are serious models, like the Hartle-Hawking no-boundary proposal, where the universe is described as fundamentally timeless. All of space, all of energy, all of the moments you could ever point to exist in a single, unified whole. We only perceive a beginning because we are trapped inside one thin slice of it. From our narrow perspective, the Big Bang looks like the start. From outside, it might simply be one region in a much larger map. No more the beginning than the middle of a circle is its start. Even Einstein hinted at this in his later work. He imagined a static universe, one that did not require time to move forward in order to exist. Though his version of the cosmos was later replaced by the expanding universe we now accept, the idea that the universe might not need a true beginning never disappeared. Modern physics keeps circling back to it, because every time we peel back another layer of reality, time itself starts to fade from the picture. And if there was no beginning, there may also be no end. Heat death, the collapse of stars, the fading of galaxies, all of these things might happen within the slice of reality we see. But in the larger structure, the one that contains every moment equally, nothing is ever truly lost. Every star that burns out still exists in its own fixed place. every moment in your life remains. The universe is not erasing them. You are just walking past them. This view changes everything. It means the question, what happened before the universe, might be meaningless, not because there is no answer, but because before does not exist at the fundamental level. It is like asking, what is north of the North Pole? The question dissolves when you see the whole spherical shape. If that is true, then maybe the universe does not need time to explain itself. Maybe time is only a way for us to navigate what was always there. And if that is the case, then the Big Bang was not a beginning. It was simply the point where the part of the universe we inhabit became visible to us. This way of thinking might feel unsettling, but it is also strangely calming. If there was no true beginning and there will be no final end, then the universe is not rushing toward anything or away from anything. It is simply there, complete, unchanging in its totality while we move through it. But there is still one question left hanging in the air. If the universe is timeless in this deep sense, how do we explain the way we feel time moving? Why do we remember yesterday but not tomorrow? What gives time its strict forward direction, if not some cosmic clock? If you have ever watched a clock in a quiet room, you can almost hear it speaking. Each tick is small, precise, certain. But in the world of the quantum, that certainty disappears. Time itself seems to lose its voice there. It does not tick. It does not march forward. In fact, it becomes something far stranger, something that might not exist in the way we think at all. At the smallest scales of reality, the rules change fundamentally. Particles do not move from point A to point B like little marbles on a table. They exist in clouds of probability, spread out as if they are in many places at once, until you look. And here is the part that unsettles everything. The equations that describe this quantum world do not naturally need time. They do not say first this happens, then this. They describe relationships static and timeless between possible states. The flow we feel must come from somewhere else, and that somewhere else is likely the only physical law that actually cares about direction, the law of increasing disorder. One of the most striking formal examples is the Wheeler-DeWitt equation, which we introduced earlier. This equation is a serious, fundamental attempt to combine the laws of quantum mechanics and general relativity. The astonishing result is that, in its original form, it has no time variable at all. None. The variable for time, $t, is not included in the equation. The equation attempts to describe the entire universe as a single wave function, a concept borrowed from quantum mechanics. Because it describes the whole universe, it treats every possible state of existence as if it already exists simultaneously. What we call time is just a way of looking at the configuration from inside, not a fundamental property of the universe itself. In this view, the flow of time is purely like a story we tell ourselves while flipping through the pages of a massive finished book. The book does not change just because we are reading it. The pages are already there. The only thing truly moving is our place in the narrative. Quantum mechanics suggests that, at its foundation, the universe might be exactly like that, a static, complete whole, where what we experience as the present is simply the page we happen to be standing on. This is not just theory. Even experiments hint at this deep, underlying timelessness. Consider quantum entanglement, where two particles can be separated by vast distances, even light years. When you measure a property of one particle, the other responds instantly, as if distance and, crucially, time do not matter at all. It is not that information is moving faster than the speed of light. It is that In the quantum view, both particles are inherently part of a single, timeless system. There is no before or after between their states. They simply are. This is why many physicists argue that time is not fundamental. It emerges only when you zoom out, the way temperature emerges from countless molecules bumping together. At the raw quantum level, time may vanish, replaced by a kind of raw, unstructured reality, a network of possibilities. You only feel the ticking clock when you step back far enough for the world to look familiar again, allowing the rules of classical physics to apply. It is almost unsettling, but it fits the mathematical pattern. The deeper we dig, the more time slips through our fingers. Classical physics gave us time as a steady, reliable backdrop. Einstein showed us it could stretch and bend. Now, quantum mechanics whispers that it might not even be there at the very bottom. What we experience could be no more than a reflection of how we, as observers, interact with this underlying, timeless structure. And yet, if time is not there at the quantum level, why does it appear so convincingly in our everyday lives? Why does the universe look so ordered, with one thing happening after another, with a past we can remember and a future we can only imagine? This is where the boundary between the quantum world and the world we see every day becomes critically important. Somewhere between the two, time reappears, not as something the universe fundamentally possesses, but as something that emerges when enough particles, enough interactions, and enough complexity come together to give us a sense of sequence. This transition is governed by a quantum process called decoherence. Decoherence is what forces the universe out of its fuzzy, timeless state of possibilities and into the definite, sequential reality we experience. It is not time that creates change. It is change that, through the process of decoherence, creates the perception of time. If that is true, then time is nothing more than a powerful tool our minds use to make sense of a universe that does not actually need it. And if that is the case, then the universe can exist perfectly well without time. It already does, beneath everything you see. But that brings us to another strange corner of the story, a place where gravity bends reality so far that the very concept of before and after starts to break apart. If you want to see where time begins to break down completely, you do not have to look at the smallest particles. You can look at the largest objects in the universe, black holes. These strange, silent giants do not just warp space, they stretch time until it almost disappears. Imagine falling toward a black hole. From far away, someone watching you would see you slow down. Your movements would become sluggish. Your clock would tick more and more slowly. As you reach the edge, the event horizon, you would appear to freeze. From the outside, time for you would come to a virtual halt. You would be trapped on the edge forever, suspended in a single moment that never seems to end. But from your own perspective, nothing unusual would happen. You would keep falling, you would cross the horizon, you would not feel time stop. It would be everyone else far away in the universe who would seem to speed forward without you. This is the profound paradox of black holes. They divide reality into two viewpoints, both equally valid, both completely different. Time is not absolute. It bends until the word almost stops making sense. And it gets stranger. Inside the event horizon, the very roles of space and time switch. Moving forward in time becomes as inevitable as falling deeper into the black hole's center. You cannot resist it. There is no turning around. In a sense, time inside a black hole is not something you experience anymore. It becomes a direction, a path you cannot escape, like sliding down a slope that only goes one way. For physicists, this is not just a curiosity, it is a critical clue. Black holes take the flexible time of Einstein's relativity and push it to its absolute limit. If time can slow to nothing at a black hole's edge, then maybe it was never fundamental to begin with. Maybe black holes are showing us the skeleton of the universe, the place where time is stripped away to reveal something deeper that does not depend on it at all. Even the horizon itself adds to this mystery. It is not a physical surface. It is a boundary drawn by the rules of space-time geometry. Cross it, and no signal can ever come back out. But for someone far away, that boundary looks like the edge of time itself, a place where moments stack up and never move forward. If you could stand there and look at it, you would see the last moment of anything that fell in, held in suspension for what appears to be eternity. And beyond that horizon, we run out of certain answers. General relativity says there is a singularity at the center, a place where density is infinite and our current understanding of physics collapses. Quantum physics suggests there might be no singularity at all, just a different kind of timeless region, one where space and time stop being meaningful concepts. Some scientists even argue that what happens at a black hole's horizon is the key to understanding the arrow of time itself, because black holes are places where information is destroyed. They are intimately linked to entropy, the universe's inherent tendency toward disorder. If you can explain why time breaks there, you might explain why it exists anywhere else at all. This is why black holes are more than just cosmic oddities. They are natural laboratories for the deepest questions in physics. They show us what happens when time is pushed to the edge of existence. And in their silence, they might be telling us that the universe does not need time to be what it is. But black holes are not the only places where time fades. Beyond their event horizons, in the first fractions of a second after the Big Bang, and in the quantum fabric beneath everything, the same pattern keeps appearing. Time is not fixed. It is not universal. And in the most extreme conditions, it might not exist at all. If that is true, then we are left with a strange conclusion. Time might only be a convenient story that applies to where we are, at the scale we live in, and with the conditions we know. Step outside those conditions, whether at the edge of a black hole or at the foundation of the universe itself, and the story unravels. The question now is what that means for us. Because if there are places in the universe where time does not exist, then maybe time is not the rule. Maybe it is the exception. And if that is the case, we need to ask what reality looks like when you stop treating time as the thing that keeps it all together. If you could rewind the universe, not just back to the first stars or the first atoms, but all the way to the very beginning, you might expect to find time itself ticking faster and faster, counting down to that first instant of creation. But what if instead of speeding up, it stopped? What if, at the earliest stage, before the universe as we know it began, there was no time at all? This is not just a thought experiment. In some of the most advanced theories in physics, the early universe was not just tiny and hot, it was timeless. The equations that describe the universe at its smallest scale, before it began expanding, do not include time as a necessary variable. Instead, they describe a kind of static quantum state, a frozen hole with no before and no after, no motion and no required change. It sounds strange, but it is not without precedent. In quantum mechanics, particles do not move in the way we normally think. They exist in superpositions, in many states at once, until something, an interaction, a measurement, forces them into a single, definite outcome. The universe, before the Big Bang expansion started, may have existed in a similar, timeless, quantum superposition. The universe at its very beginning may have been something like that, a vast, timeless superposition containing every possibility at once, waiting for something to break the deep symmetry and create what we now call time. When cosmologists discuss this state, they sometimes describe the early universe as being governed by a quantum foam, or existing within the wave function of the universe, a state where the concept of time simply does not apply. Nothing changes in this state because there is no before or after to compare. It is as if the universe was holding its breath, not yet moving, not yet flowing, not yet dividing itself into the moments we now experience. Only later, as the universe began to expand and cool, would time as we know it have emerged, like a detailed pattern crystallizing out of something that was once completely still and featureless. Some researchers even compare this to how temperature only appears when a vast number of particles come together. A single particle does not have a temperature. It is only when you have an enormous collection of them interacting that hot and cold become meaningful concepts. In the same way, the earliest universe may not have had time. Only when it grew and became structured enough for change to take shape did time switch on. This means that asking, what happened before the Big Bang, might not make sense at all. If time itself did not exist, there was no before for anything to happen in. What we think of as the beginning might simply be the precise point where time first became meaningful, where a timeless quantum state gave way to the familiar ticking sequence that governs our lives. It is an unsettling picture because it erases the idea of a fixed starting line. The universe does not spring out of nothing in a single explosive moment. Instead, it emerges smoothly, naturally, out of a state where nothing was moving and nothing needed to move because there was no time to measure motion in the first place. If this is true, it reshapes the way we think about everything. It means time is not a fundamental feature of the universe, but a byproduct of its growth. It did not exist until there was something for it to measure. And if it had to emerge, then it is not unreasonable to think it could also vanish again, leaving behind the same kind of timeless state that may have existed at the start. This idea is not just abstract theory. Physicists working on quantum gravity and cosmology use it to build sophisticated models of the early universe that fit what we see today. The tiny ripples in the cosmic microwave background, the faint afterglow of the Big Bang, may be the faint, earliest fingerprints of this profound transition from timelessness to time. So, if the universe began in a state where time did not exist, and if time only later emerged as a feature of the expanding cosmos, it leaves us with an extraordinary possibility. The universe does not need time in order to be real. Time is something we experience because of where and how we exist, not because it is built into the foundation of everything. But if time can switch on, could it also be something that switches off? Could there be places even now where time is completely absent, the same way it may have been in the beginning? Places not at the edge of the universe, but hidden in the deep structure of reality where change does not happen and the ticking of the cosmic clock goes silent. When you think about the future, you probably imagine something open, unwritten, still waiting to happen. The past is fixed, the present is now, and the future has not arrived yet. It feels obvious, unchallengeable. But according to one of the strangest and most widely discussed ideas in physics, that might not be how reality works at all. This idea is called the block universe. And in this view, The future is not something that happens later. It is something that already exists. Einstein's theory of relativity opened the door to this perspective. In relativity, there is no single, universal now that stretches across the universe. What is happening for you right this moment might be in someone else's future or in someone else's past, depending on how fast they are moving or where they are located. That means there is no cosmic line dividing the past from the future. All moments are equally real. They simply exist in different places in space-time, like different geographical locations on a map. Imagine holding a book in your hands. Every page in that book exists at the same time. The page you are reading now feels like the only one that is truly real, but the other pages are not waiting to be written. They are already there, printed and bound. You will get to them eventually, but they do not spring into existence when you turn the page. They have been there from the start. In the same way, the block universe suggests that every single moment, yesterday, today, tomorrow, exists all at once, laid out in a vast, four-dimensional structure. You are just moving through it, one page at a time. This view changes everything about how we think of time. It means that the future is not a blank space waiting to be filled. It is as real as the past. You just have not reached it yet. And if that sounds unsettling, it is worth remembering that this is a natural consequence of physics as we know it. Nothing in Einstein's equations picks out a special now. The fundamental laws of nature treat all of time the same. In this framework, time does not flow. There is no universal clock ticking forward. Instead, what we call the passage of time is simply the way our minds experience movement through this unchanging structure. We do not notice the other moments because our consciousness can only focus on one slice at a time. This idea even offers a new way of thinking about memory. We remember the past not because it is gone, but because it is the part of the block we have already moved through. The future feels unknown, not because it does not exist, but because we have not reached it. From outside the block, from a perspective beyond our experience, there would be no difference between them. Every moment would be equally real, sitting there in the fabric of space-time, unmoving and eternal. Of course, this raises difficult questions. If the future already exists, does that mean everything is predetermined? Are our choices illusions? Some physicists and philosophers argue that even if every moment is fixed within the block, the experience of making decisions is still an essential part of the structure. The act of choosing, the sense of freedom, is just as real as any other event. The block universe does not erase it. It simply contains it. This perspective can be unsettling, but it can also be strangely comforting. If every moment already exists, then nothing is ever truly lost. The happiest day of your life, the people you have loved, the quiet evenings you thought were gone, they are still there, woven into the structure of the universe. You have only moved past them, but they remain. And if that is true, then the same must be true of the future. Somewhere in the block, every step you will ever take is already part of the whole. You do not have to worry about catching it. It is already there, waiting for you to arrive. But there is still a deeper question hiding inside this idea. If time is just a dimension of the block, and if all moments exist at once, why do we move through it in only one direction? Why do we not experience the future the way we experience the past? Why does time, even in a timeless universe, still feel like it has an arrow pointing strictly forward? If the universe is a vast block of moments, each one already there, then why does your life feel like it is moving? Why do you feel yourself changing, aging, and living through time instead of simply existing in it? The answer may be that you are not just living in one kind of time, you are living in two, which leads to the most important missing piece of the puzzle: entropy. The first time is cosmic time, the time of physics, the one measured by the ticking of atomic clocks and the bending of space-time. This is the time that satellites rely on, that GPS systems must correct for, and that astronomers use to track galaxies moving billions of light years away. It is objective, impersonal, and governed by the laws of relativity. The second is biological time, the time you carry inside your body. You can feel it in the beating of your heart, the rise and fall of your breath, and the rhythm of your sleep. It is in the gradual changes of your cells, and in the subtle way your body keeps track of the day, even without a clock. Unlike cosmic time, biological time is deeply personal. It is tied to memory, perception, and the physical processes that make you who you are. These two times do not always perfectly match. In cosmic time, you might be hurtling through space at incredible speeds without ever noticing. In biological time, a moment of fear or joy can stretch out endlessly, while an hour spent in boredom feels like it lasts forever. Your body's time is elastic, bound not to the precise equations of relativity, but to the way you experience life. Even more fascinating, cosmic time and biological time interact in subtle ways. Astronauts who live aboard the International Space Station experience time just a tiny fraction of a second slower than those of us on Earth because of their speed and position in space. Their bodies age imperceptibly differently compared to ours. In a way, they are living in slightly different slices of cosmic time, even as their biological clocks continue ticking along in the only way they know how. And yet, no matter where you are or how fast you move, your body's time is always grounded in the same familiar rhythm. You sleep, you wake, you grow older. Your brain knits these changes into a story. But the direction of that story, the unwavering forward movement, is not found in the bending of space-time, nor in the quantum fog. It is found in the simple, statistical truth of disorder. And that story gives you the sense of moving forward through a universe that, from a much larger perspective, may not be moving at all. This feeling of being pulled from the past into the future is why biological time is what makes the arrow of time feel so real. This arrow, the persistent feeling that time only travels in one direction, is not actually written into the fundamental laws of physics. The equations that describe gravity, motion, and even the quantum world work just as well if you run them backward. If you filmed a ball flying through the air, the physics of the throw would look perfectly fine when the video is played in reverse. The law itself does not care if time moves forward or backward, but your body, like everything else made of matter in the universe, is tied to the one true directional physical law: entropy. Entropy is the scientific term for the slow, inevitable increase of disorder or randomness in a closed system. It is the core concept behind the second law of thermodynamics, which states that the total disorder of the universe must always increase. This is why you remember the past, but not the future. When you remember the past, your brain is organizing a chaotic collection of electrical signals into a coherent memory, a shift from high disorder to low disorder. The past is low entropy because it has already happened and is fixed. The future is high entropy because it contains countless possible arrangements of particles and events. It is why a broken glass does not put itself back together. The ordered state of a glass on a table is highly improbable. The scattered, broken state on the floor is highly probable and disordered. The transition from order to disorder is the only process in the cosmos that strictly enforces a direction. Your biology, from the growth of your cells to the way your brain weaves moments into memory, is a one-way, increasing entropy process unfolding inside a universe that, at its deepest level, might be timeless. When you think about it that way, you can see why your sense of time feels so strong. It is not just the ticking of a clock. It is the sum of everything your body does, always moving from a state of less disorder to a state of greater disorder. Without this biological and thermodynamic layer, you might not feel time passing at all. You would simply exist, like everything else in the block universe, without ever noticing that you were in motion. But this dual existence, cosmic time on one side, biological time on the other, creates a fascinating tension. It means that while the universe may be timeless as a whole, your personal experience of it is built entirely around irreversible change. You live in the part of the picture that moves and degrades, even if the larger picture never does. And that might be the reason time feels so precious. It is not a fundamental feature of the universe. It is a fundamental feature of you. You carry it with you everywhere, and it shapes the way you see everything else. But there is another layer to this, because if your body can experience time differently from the universe, what happens in the one place where your sense of time naturally fades away almost completely, where minutes and hours blur and the ticking of the clock loses its grip? That place is not out in deep space or at the edge of a black hole. It is much closer. It is the world you enter every single night when you sleep. Every night, without consciously thinking about it, you step into a world where time almost stops. You close your eyes, and the familiar rhythm of seconds and minutes fades away. Hours pass, but you do not notice them. You might dream, and in those dreams, entire stories unfold. Yet, when you wake, you cannot reliably say how long any of it lasted. This is the strange way your brain escapes time in sleep. Sleep is not just rest. It is a shift in how you experience reality. When you dream, the brain networks responsible for tracking time become quiet. Neuroscientists have found that the parts of your mind that keep track of duration and sequence take a deliberate step back. Instead, the brain focuses on weaving images, sensations, and fragments of memory into something that feels continuous but is not measured against any external standard. A dream can feel as if it lasts for days or only seconds, and there is no reliable way to measure the difference. Your mind is not counting seconds. It is building a world where seconds do not matter. In this sense, sleep is one of the closest experiences you have to a universe without time. You still exist. Your thoughts still move, but they move without the rigid frame of before and after holding them in place. You do not wake up in the middle of a dream and wonder what time it is. You only do that when you return to the waking world, where the clock rules again. This nightly escape hints at something profound. If time can lose its hold on you so easily, if your brain can function in a state where time is irrelevant, then maybe time is not as essential to consciousness as it feels. Maybe it is just one mode of perception, one way of organizing experience among many. This also explains why sleep feels so restorative. For a few hours, you are not just resting your body. You are stepping outside the relentless push of time and the increase of entropy. You are slipping into a state where there is no rush, no countdown, no constant awareness of the clock. It is worth noticing how similar this is to what physics tells us about time itself. Beneath the surface, in the quantum world, there is no ticking clock. Time emerges only when you zoom out far enough to see the resulting complexity. In a way, your mind seems to do something similar. When you dream, it stops tracking time at the scale you are used to. It drops into a lower, less structured state where time is simply not part of the picture. But then you wake up, you look at the clock, and without thinking, you step back into the steady rhythm of seconds and minutes as if nothing happened. It is only when you pause to consider it that you realize how strange this is, that every single night you pass through a world without time and come back without even noticing the transition. If your mind can so easily exist without time, even for a few hours at a stretch, then maybe time really is not the unshakable foundation we think it is. Maybe it is something you use, not something you are. If you have ever stood on a mountain and looked down at the valleys below, you felt gravity's pull in the most ordinary way. But what you might not realize is that gravity is not just holding you in place, it is quietly changing the way time passes for you. Einstein's theory of general relativity revealed something extraordinary. Gravity does not just bend space, it bends time. The stronger the gravity, the slower time moves. It is not a trick of perception or a limitation of your senses. It is real. We have tested this in extremely precise experiments using highly specialized atomic clocks. Scientists have measured the difference in time between clocks separated by just a few feet of height. The clock closer to the ground, where Earth's gravity is slightly stronger, runs infinitesimally slower than the one higher up. The difference is minute, a few fractions of a second over a human lifetime, but it is there, written into the fabric of space-time. This effect becomes even more dramatic near massive objects like black holes. There, gravity bends space-time so severely that time slows almost to a complete stop. If you stood near the edge of a black hole while someone else remained far away, they would watch you move in exaggerated slow motion. Minutes for you might become centuries for them. From their perspective, you would appear frozen on the brink forever while the rest of the universe raced ahead. And yet, from your point of view, nothing would feel unusual. Your seconds would pass normally. This is one of the strangest things about time dilation and gravity. Every observer's experience is self-contained. No one ever feels time slowing down for themselves. You only see it when you look at someone else, when you step outside your own local clock and compare it to another. This means there is no single master clock for the universe. There are only countless local times, each shaped by the local presence of mass and gravity. A clock on a satellite in orbit runs faster than one on Earth because it is farther from our planet's strong gravity. GPS systems must correct for this, or their calculations would be hopelessly inaccurate. Every piece of technology that depends on precise timing is, in its own quiet way, a reminder that time is not absolute. If time can be stretched this way, it is hard to keep thinking of it as something fundamental. A universal, unchanging flow would not bend under gravity, but time does. It adapts to the shape of the universe, to the curves of space-time itself, and in some places, those curves push it nearly to zero. It is in those extremes near black holes, in the early universe, and deep inside the equations of physics that we begin to see what might really be happening. Time is not the foundation, it is a side effect. Gravity shows us this clearly. As space bends, time bends with it, like a shadow that moves because something deeper is shifting underneath. And if that is true, then maybe time does not define reality. Maybe it is the other way around. the shape of reality defines time. This brings us back to the ultimate question of the arrow of time. If the universe is a static block, and if the laws of physics are time-symmetric, meaning they work forwards and backwards equally well, why do we only move in one direction? The answer, as we noted, is entropy. The arrow of time is not a fundamental property like the speed of light. It is a statistical tendency. The universe started in a state of extremely low entropy, highly ordered, incredibly concentrated, right after the Big Bang. Since the second law of thermodynamics dictates that entropy must increase, the universe is statistically forced to move from that state of low disorder to states of greater disorder. Imagine shuffling a deck of cards. You start with an ordered deck, low entropy. Every time you shuffle, the deck becomes more disordered, high entropy. You never, ever expect the random shuffling to perfectly put the deck back into its original order. That statistical improbability is the entire source of the feeling of time passing. We experience time as moving forward because we are observing the universe moving from improbable order toward probable disorder. So, when we ask why, we remember the past, but not the future. The answer is simple. The past is defined by a more ordered state, lower entropy, that has already been recorded by our brain. The future is an unrecorded, highly disordered state, higher entropy. We are moving through the block universe, but the only direction that makes sense for our consciousness is the direction in which disorder increases. Time, therefore, is not a force. It is the label we give to the statistical movement of the universe toward increasing chaos. If the universe somehow reached a state of maximum entropy, the heat death, where everything is uniformly spread out and totally random, then change would stop. And if change stops, the statistical arrow vanishes. And if the arrow vanishes, time, as we know it, would effectively cease. The universe would simply be frozen in a state of ultimate, unchanging equilibrium. When the shape of space-time changes enough, when gravity is strong enough, or speed is fast enough, time itself almost disappears. This realization is a quiet one, but it fundamentally changes the nature of reality. Because if time depends entirely on gravity and motion, then it is not hard to imagine a universe, or even specific regions within our own, where the influence of gravity or the complete absence of change makes time meaningless. And that leads us to an even stranger question. If gravity can slow time down until it nearly stops, what would it mean to live completely outside of time altogether? Not merely in theory, but in the way physics seems to suggest is possible in certain extreme places at the edge of reality. If you try to imagine what it would feel like to live outside of time, your mind almost immediately runs into a wall. We are so used to measuring life in seconds, minutes, and years that it is nearly impossible to picture an existence where none of those markers apply. But physics keeps pointing us toward a deeper reality where time might not be fundamental. If that is true, then there must be a way to at least glimpse what that state might be. Start by deliberately stripping away everything you normally associate with time. No clocks, no sunrises or sunsets, no aging, no before or after. What is left is not empty. It is still the universe. The stars would still exist. Matter and energy would still be there. But without time, nothing would change. There would be no motion, no cause and effect, just a complete and unmoving whole. This is not science fiction. It is what many advanced theories of physics actually describe at the most fundamental level. In the equations of quantum gravity, there is no time variable. The universe is treated as a single, static object with every possible state it can have existing simultaneously. In this view, time is not something the universe has. It is something that emerges only when you look at it from the perspective of someone inside it. If you could step outside of that perspective, you would not see events unfolding. You would not see the universe happening. You would see everything at once. Every moment that has ever been or ever will be coexisting like permanent points on a vast, intricate map. There would be no need to move from one moment to the next because every moment would already be there. From our point of view, this is nearly impossible to imagine because our experience of life depends entirely on change and sequence. We feel time because our bodies change, because we remember the past, and because we anticipate the future. Remove those three things, and what is left would not feel like life at all. It would be something entirely different, a state of pure existence without any sense of passage. And yet, in a strange way, you already brush against this idea every day. When you sleep deeply and wake up with no memory of the night, hours pass, but it does not feel like they did. It is as if you jumped from one point to another without crossing the space between. For you, those hours did not exist in any conscious way. While that is not what living outside of time would be like, it is a hint. It shows how easily your mind can skip over the experience of duration and simply be in one moment then another without feeling the movement between them. If time really is something that emerges rather than something that is fundamental, then living outside of it would not mean floating in darkness or nothingness. It would mean being in a state where everything simply is. No waiting, no moving forward, no sense of loss, because nothing can ever be lost if all moments exist forever. This is why some physicists and philosophers see this idea not as something frightening, but as something strangely peaceful. If the universe at its deepest level is timeless, then everything that has ever happened and everything that ever will happen is woven into it permanently. Nothing vanishes. Nothing is erased. We only experience it one piece at a time because that is the only way our sequential brains can process it. But if that is true, then it raises a new, critical question. If time is not fundamental and if reality might be timeless underneath, why do we experience time the way we do? Why do we live in this single, one-way flow instead of seeing everything at once? The answer might not be that time is an illusion, but that it is a kind of lens, one that turns a timeless universe into something we can successfully live in. And to understand that lens, we need to look at what happens if we push this idea even further. What if time stopped entirely, not just for you, but for the whole universe? Would anything actually change? If time suddenly stopped, what would you expect to happen? Maybe you imagine everything freezing in place, the planets halted in their orbits, waves paused in midair, and every thought in every mind suspended. But that is the paradox. If time really did stop, there would not be a moment for you to see it. There would not even be a you to notice. When you take time away, change disappears with it. Motion, memory, and cause and effect only make sense inside time. If time stopped, nothing would happen, not even the stopping. The universe would not freeze. It would simply be in a state that has no before and no after. This is one of the clearest reasons physicists argue that time is not a fundamental feature of the universe. It is not that there is a cosmic clock that could run out or suddenly halt. Time does not seem to exist independently at all. What we call time might only be our way of keeping track of change and complexity. Take away the changes, and you do not just stop time, you remove the very need for it. You can see a shadow of this idea in the mathematics of physics. The equations that describe the universe do not need a universal ticking clock to work. They only describe relationships, how one thing depends on another, how matter and energy interact. When nothing changes in those relationships, time becomes irrelevant. It simply falls out of the picture. Even your own experience supports this in small ways. Think about the moments when you have completely lost all sense of time, maybe while staring at the sky or drifting towards sleep. Time did not really stop, but your awareness of change became so faint that it almost felt like it had. In those moments, you were not counting seconds, you were simply existing, and nothing seemed to move. This is why, if time were to stop in the deepest sense, nothing would actually feel different. There would be no feeling at all. A timeless universe would not be empty or dead. It would be complete. Everything would exist simultaneously, every event, every detail, but there would be no motion through it, no frame after frame, no story unfolding, just the whole, all at once. And this is not just speculation. In some theories of physics, especially in quantum gravity, this is exactly how the universe is described. Time does not appear in the equations. The universe is treated as a static object. What we call the flow of time is not something the universe is doing. It is something we experience because we are inside it. We are moving from one part of that static whole to another, and our minds translate that motion into a story. If you removed that story, if you could step outside of it, you would not see time stopping. You would see that it was never running in the first place. And if that is true, then asking what happens if time stops might be like asking what happens if you turn off the light in a room full of objects. The objects do not vanish. You just stop seeing them in the way you used to. This is not an ending. It is another profound shift in perspective. Because if nothing would change if time stopped, then time might not be the foundation we have always believed it was. It might be a convenient way for us to move through something that was never moving at all. And if that is the case, then we need to take one more step. Because there is an idea that builds on this, one that many physicists and philosophers quietly agree on, that the only thing we ever truly have is the present. Not because the past is gone or the future is unreal, but because every moment is part of a single, eternal now. If you have ever sat quietly and felt a moment stretch until it seemed to hold the whole world in it, you have brushed against an idea that both philosophers and physicists have been circling for centuries. The core idea is simple. The only thing that truly exists is now. From the perspective of physics, this comes directly from relativity. There is no universal now, no single slice of time shared across the entire universe. What you call the present depends entirely on where you are and how you move. Two people in different places can profoundly disagree on what now even means, and both can be mathematically right. That alone is enough to suggest that the flow of time is not fundamental. It is a matter of perspective. Philosophers have been saying something similar for much longer. For them, the present is not just a fleeting point between past and future. It is the only place anything ever actually happens. You cannot live in the past. You cannot stand in the future. All you ever actually touch is this single continuous moment. And here is where science and philosophy quietly meet. In some interpretations of modern physics, the universe is not flowing from one moment to the next at all. Every event, every heartbeat, every star igniting, every word you will ever speak exists at once, permanently embedded in the fabric of space-time. From outside of it, there is no past, no future. There is only the static, eternal whole. There is only a single, unified, eternal structure. What we call now is simply the point where our personal awareness happens to be focused. This does not mean the past is gone or the future is unreal. It means they are both as profoundly real as this very instant. You just cannot stand in all of them at once. Your mind is the traveler, and the present is the singular path it takes. But the path is already there, laid out in the geometry of space-time. You are not carving it out of nothing. You are merely following it. Strangely, this idea is not bleak or empty. It is deeply comforting. If every moment exists forever, then nothing is ever truly lost. The laughter of a child, the warmth of a single afternoon, the stars you saw on a clear night, all of it still exists, written into the universe as unshakably as the laws of physics themselves. You have simply moved past those places, but they are still there, perfectly preserved. And if the future is also part of this eternal structure, then it is not rushing toward you like a wave you have to outrun. It is already waiting. Every step you will ever take is already there, part of the whole, just as unshakable as your past. This is the eternal now. It is not a moment that passes. It is the entire universe seen all at once, contained in a single, unmoving structure. Philosophers reached this conclusion by reflection and logic. Physicists reached it by mathematics and observation. And both perspectives quietly meet in the same place, the realization that time as you experience it is only one way of looking at something much bigger and far quieter than the ticking of any clock. But there is one more essential step we can take. If the universe is already complete, if every single moment exists in an eternal now, then maybe you do not need to hold on to the concept of flow or rush at all. Maybe it is enough simply to rest in it, to exist in this slice of infinity, knowing that nothing is ever truly lost and nothing ever truly ends. And that brings us to the final thought that ties all of this together. Not physics, not philosophy, but the simple human way of living inside a universe that does not need time at all. If everything we have explored is true, if time is not fundamental, if every moment already exists, if the past and future are as real as the present, then we are left with a choice of language. Is the universe without time, or is the universe nothing but time, stretched out in its entirety, waiting to be seen? These two ideas sound completely opposite, but in a profound way, they might be describing the exact same thing. When physicists describe the block universe, they talk about time as if it is laid out like space, an immovable dimension that does not move, but simply is. From that perspective, there is no flow, no universal now, and thus, in a sense, no time passing. But that does not mean there is no time at all. It means the universe might be made entirely of it, a vast structure composed of every single moment, every change, every event existing together in one unbroken whole. If that is true, then time is not something that passes. It is something that is. The future does not arrive any more than a distant mountain suddenly pops into existence when you walk toward it. It was always there. You just could not see it yet. And yet, from our perspective, this does not feel like a static universe. We live inside time as if it were a river. We measure it. We chase it. We feel it moving around us. That powerful feeling of movement might only be the way our consciousness travels through this larger structure, one point of awareness sliding along a dimension that never physically changes. This motion of consciousness, always moving from order to disorder, is the human mechanism that generates the flow. But even if the universe is timeless at its core, time is still what we see from the inside. This is why the question is not easy to answer with a simple yes or no. To say the universe has no time would be true from the perspective of the fundamental equations, which contain no variables for flow. But to say the universe is made of time of every moment that ever was or will be might be just as true from the perspective of geometry. The difference is not in the universe itself. It is in how we, the observers, experience it. And that brings us back to something important. If every moment already exists, then the universe is not rushing toward anything. It is already complete. You are not racing against time. You are simply walking through a reality that, from a higher perspective, is already finished. But for you, here inside it, time still matters profoundly. It is what gives shape and narrative to your life. It is what lets you experience the story one moment at a time instead of being overwhelmed by the entire thing at once. It is the reason you can remember yesterday and dream about tomorrow. Without that temporal lens, existence might be too vast and too complex to even understand. So maybe the universe is both timeless and made of time, depending entirely on how you look at it. From the external, mathematical view, it is silent and still. From the internal, human view, it moves, breathes, and unfolds. And both views, impossible as it seems, can be true at once. If that is the case, then you do not have to choose. The final conclusion of this vast exploration from the bending of time near black holes to the timeless quantum world and the block universe where every moment exists at once is that you can live in time without being trapped by it. You can acknowledge the mathematical certainty of the timeless, static cosmos without ever needing to leave the present moment you feel so strongly. You can let these two profound ideas exist side by side, the way physics and philosophy so often do, each one pointing toward a universe far stranger and far quieter than the ticking of any clock. It is tempting to think that completely understanding the ultimate nature of time will fundamentally change how we should live inside it. But the truth is simpler and more practical. You do not need to solve time. You only need to register and accept the reality of the moment you are in. Because no matter how strange the universe may be, no matter how many serious theories point to time being an emergent, statistical illusion, this specific moment is still here. Your nervous system is registering this information. Your heart is beating. The world, in its quiet, entropic way, is still unfolding sequentially around you. You do not have to strain to reach back into the past or exert energy to rush forward into the future to find something real. It is already here, perfectly contained in the present, waiting for your consciousness to observe it. If time is a vast, unmoving landscape, you do not have to see the entire map to successfully walk the path directly in front of you. If every moment already exists in the fabric of space-time, you do not need to hold on to the ones that came before or frantically rush toward the ones that are still ahead. They are already there, perpetually preserved, safe in the static structure of the universe. All you have to do is take the single step that is in front of you now. And perhaps that is the most crucial takeaway. Physics can strip away the illusion of time's flow, but it does not erase what it feels like to live inside that flow. In fact, understanding the mathematical certainty of the eternal now can make each second feel even more substantial and valuable. Because if every moment is already immortal, then this one, the one you are experiencing right now, is not going anywhere. It is fixed and yours, perpetually existing within the architecture of reality, whether you actively notice it or not. So, take a deep, steady breath Let yourself feel the weight of this single instant without trying to stretch it, shrink it, or trap it in your hands. You do not need to fight time. You do not need to solve it. You only need to rest in it, the way the universe has been resting in every configuration since the beginning, if there even was a beginning. All of this, the timelessness described by physics, the endless geometry of space, the quiet truth that every moment exists forever, leads to one simple, unifying conclusion. You do not have to achieve perfect comprehension of time to be at peace with it. You only have to live in it, one breath, one observation, one present moment at a time. And that is enough. We must accept that our perception of time is a brilliant, necessary biological construct. The entire reason we perceive a flow in the static block universe lies in the difference between the simple, reversible laws governing fundamental particles and the complex, irreversible processes governing our conscious minds. Our brains, as complex systems, are inherently driven by entropy, the continuous movement from an ordered state to a disordered state. This process of aging, remembering, and making choices is what stitches the static frames of the block universe together into a moving story. If our consciousness could perceive all moments simultaneously, we would be overwhelmed by infinite information and infinite possibilities. Time, in this sense, is the specialized cognitive tool that prevents informational overload. It acts as a temporal filter, focusing our awareness onto one thin, workable slice of the space-time structure at a time. It is the mechanism that allows us to distinguish the past, the recorded, lower entropy states we have processed, from the future, the unrecorded, higher entropy states we are moving toward. Therefore, time is not an error in the system. It is the vital interface required for consciousness to exist and operate within the cosmos. It is a necessary fiction that gives your mind a manageable, sequential way to move through the infinite complexity of the block universe. It is the lens that focuses a four-dimensional reality into a single, understandable moment. This means the question, can the universe exist without time, is answered by a quiet paradox. Yes, the universe can and likely does exist without time, at its core, timeless, static, and whole. But simultaneously, your personal reality, your consciousness, your memory, and your ability to function demand that time exists as a directional flow. You are living at the exact point where these two truths meet. The external universe is an eternal structure. The internal universe, your mind, is the observer that creates the flow to navigate that structure. You are the projector, taking the static frames and creating the motion. So, let the deep structure of reality remain silent and still. You have your own local, personal clock, your own directional arrow given by your biological need for sequence. Let that arrow carry you softly, one breath at a time. You do not need to solve the paradox. You only need to rest in the knowledge that you are here, now, and that this moment, the one you are in, is permanently fixed in the vastness of the cosmos. You are here, in this instant, and that is enough. You do not have to hold on to time. You only need to let its statistical current carry you softly. For now, the deep exploration of time comes to a close. There is always more to observe, more data to process, and no rush to get to the next discovery. Let the thoughts settle. Let this moment stretch, slow and unhurried. The ultimate structure of the universe is secure. You just rest in the knowledge of the eternal now, perfectly safe, perfectly real, and eternally present. The harmony between the eternal structure and the subjective flow is the most important idea to carry forward. We have established that the universe, in the view of physics, is not a clock that ticks. It is a completed, four-dimensional structure. Yet, our lives are defined by seconds. This is the ultimate lesson. The objective reality of the cosmos is one thing, and the subjective necessity for experience is another, and both must be respected. The fact that the fundamental laws of physics are time-symmetric, they look the same, running forward or backward while our existence is irreversibly one-directional, is a profound clue. It shows that time's arrow is not imposed from the top down by a cosmic mechanism, but emerges from the bottom up through the collective action of highly complex systems like us. Every time you convert energy, every time your cells divide, every time you take a breath, you are contributing to the increase of entropy, the universal measure of disorder. That statistical increase is what creates the direction of time for your consciousness. We perceive time because we are agents of change, moving the universe from one ordered state to a slightly more disordered state, frame by frame. To live outside of time, then, would mean to live without this inherent biological necessity for disorder. It would mean existing as a timeless quantum wave function, free from the constraints of memory, aging, and irreversible processes. But the moment the complexity of a conscious mind arises, the arrow switches on and the flow begins. You are the locus of this emergence. This scientific acceptance of time as a necessary tool rather than a fundamental force should quiet the anxiety often associated with the thought of time passing. We frequently worry about losing time or wasting moments because we subconsciously believe time is a limited resource that can vanish. But the block universe model, supported by Einstein's mathematics, reassures us that no moment is ever truly lost. Every past configuration of atoms, every joy, every quiet moment of reflection still exists in its fixed place within the larger structure. Your memory of an event is not a ghostly remnant of something that is gone. It is your awareness reaching back to a fixed location in the space-time map. You are not remembering something that disappeared. You are engaging with something that is permanently there. This understanding transforms the nature of loss and permanence. Furthermore, this perspective changes how we view the future. If the future is already a fixed dimension of the block, like a destination on a map that already exists, it removes the chaotic fear of the utterly unknown. It does not erase choice, but it reframes it. Your choices, your decision to read this far, your decision to pursue one path over another, are not arbitrary. They are the actual process of your consciousness, tracing the one path through the four-dimensional structure that defines your life. The experience of free will is the feeling of that tracing in real time. The quiet revolution of physics is that it validates our immediate, present experience. You do not have to wait for the universe to tick to the next second. The next second is already part of the whole. You are not waiting for reality. You are simply progressing through it. So let the final thought be one of profound structural peace. You exist at the intricate intersection of the eternal block and the irreversible arrow. You have a perfect right to feel time moving because your existence demands that flow. Yet, you also have the intellectual right to know that this flow is a specialized, local condition. You do not have to solve time. You do not have to hold on to it. All you need to do is let its statistical current carry you softly, one breath at a time, knowing that every single moment it carries you through is, in a larger sense, an eternal moment. That is where we will leave this exploration, in this very moment, which is both fleeting and fixed, both personal and universal, and which is yours, now and forever.